Okay, this tutorial is on solving the linear equations and coordinate geometry question from the test last week. I picked this one because there was some confusion about how to deal with this and finding the gradient from a linear equation in this form. We know this is a linear equation first because it tells us it's a line, and secondly because that x is to the power of 1. And there's no other x's to other powers or anything to the power of x like in an exponential function. So we know this is linear. However, the other thing that we know is that this is not in y equals mx plus c. So we're going to have to transform it if we want to find the gradient, which is what the first question is asking us. And so many students thought that 2 was the gradient. 2 is not the gradient because there's a 5 in front of the y. That is an issue. So let's work this out. We're going to 2x plus 5y equals -4. We're going to get this into y equals mx plus c form, and the first step is going to be to subtract 2x from both sides. And we're left with 5y on the left-hand side equals 2x minus 4. And then finally, because we want y the subject and we want y by itself, on the left-hand side we divide both sides by 5. And we get y is equal to -2x minus 4 over 5. Now, important understanding here is that we can split this fraction up because both of these terms are being divided by the same denominator. So we can go -2x over 5 minus 4/5. Now, if you want to, you can transform this equation into decimals. And many students prefer that. So we have -0.4x minus 0.8. Okay, so the gradient is -0.4, or same thing as -2/5. Okay, so that's our answer. These are the same. Okay, now, next question asks us for the gradient of a line that is perpendicular. And we have to remember that if we're given -2/5 as a gradient, then the negative reciprocal is the gradient of a perpendicular. And so that's going to be +5 halves. Okay? So that's our answer there. And notice they're leading us along in order to solve a more complex problem. Because the next step is to find the equation of L2, but we've been given this information about the point, a point that it's on, or that's on it. So we can use that information, and we know that point P is 5, 3. Double check that. Yes, it is. Okay, and remember that this is the x coordinate and this is the y coordinate. So we can start off using the gradient that we found from before. 5 halves x plus c. Now if we want, we can write this as 2.5 x plus c. That's the same thing in decimal form. And we're going to take the y, which is 3, and we're going to take the x, which is 5, plus c. And if you multiply 2.5 times 5, that's 12.5 plus c. And if we subtract 12.5 from both sides, we get negative 9.5 equals C. And our final equation, which is what we were trying to find, is 2.5x minus 9.5. That's our final equation. Okay, so last step, D. Using your graphic calculator or otherwise, find the coordinates of P. Well, the graphic display calculator is the most efficient way to do this. And so we can graph these. They're both in y equals mx plus c form, which is going to make it important for us. So it says that they intersect at point P, which was this point here. Oh, no, it's not this point. So I was wrong. This is not point P. This is just the point that this goes through. They intersect at point P, and we have to find the coordinates of that point. Notice that it tells us very clearly here that it wants the coordinates of P. Okay, so we have to make sure that we are looking at the looking for the coordinates of P. Now, if you go in your graphic display calculator y1 and y2, you get you'll enter one of them, the one that we just found here, and then we have the negative 0.4x plus 0.8, or is that minus 0.8? It's minus 0.8. We put those both in the calculator, and you will get something, a pair of lines that looks something like this. And this is point P, the point of intersection. And if you, you're using your graphic calculator, second calc intersection, you will find that the point P of intersection is at 3, negative 2. Now that makes sense because the x coordinate is over here, and the y coordinate is down here in the negative range. So remember that when you're showing your working on an exam, and you use your calculator to draw a sketch for your working. Okay, so that is the answer to the last part of that question. And you can move on to tackle other questions. Again, the main thing that I wanted to point out was that many of the students struggled with this, and they thought that the gradient was 2. It is not 2. You have to transform it as we did here in part A. Okay, thanks a lot, and good luck in your studying for